Hi Rahul.
Hi, sir.
So today you are doing technical setup demo for other phases, right?
Yes.
First you explain about this project overview.
Okay, so this is project regarding the AI data analysis agent. So in this last time in this demo, I performed the phase one regarding the technical environment setup and data processing part I have completed. So in that particular phase, I create a virtual environment, install all required libraries like pandas, numpy, scikit-learn, langchain, and mlflow, prothambus, and grafana libraries are installed. So you can see here, this is my requirement.txt file. In that requirement.txt file, you can see there is a panda numpy picker for data creation, matplotlib, seaborn, langchain, chromadb, fasi also, mlflow class, and prothambus client. So these are the all the requirement package I install in that particular first phase of the design. Then then after completion of that particular phase, I create these files, CSV file, that is the customer.csv, product.csv, transaction.csv, and review.csv. For creation of that particular file, I use Picker, and for data generation, and these are the all the file I generated using that particular code. So these are the files generated. Afterward, after generation of this file, this phase one is completed. Now in second phase, we are going to embedded pipeline using LangChain and Fuzzy. This enable question answering on the vector database. So in this particular phase, we use the this transaction review.csv file, and in that review.csv file, convert this CSV file into vector database with the help of OpenAI API key. So here is .env file, environment file. So in that particular environment file, I kept my private OpenAI API key. With the help of that API key, I am going to embed this review.csv file and store in the vector database. And after this storing the vector database, I am going to query on that particular CSV file, and then I am going to get the result of what we require. So these are the phases. So sir, here you can see review.embedded.py file. With the help of convert this review text file into embedding using OpenAI embedding, and this then is store this vector metadata into vector store review.index. And embedded store fuzzy for speed. And what we reason behind the embedding this particular text format, CSV format file, to get the embedding, to get the speedily data, or we can get the query very speedily, because all these data is stored in a number. So get the numbers in a speedy manner. That's why we embedded the CSV file and store in the vector database. And then we perform all the activity in that particular phase. Here environment is a data engineer, CSV schema definition, ML engineer to synthesize the data and build the baseline model, ML ops. So next phase, with the help of ML flow and Prothambus, we going to track or monitor our ML model. And front end, we can, with the help of Power BI or Grafana, we can visualize the this our data set or model. So in phase two, LangChain, vector store, and question answering on the this particular vector store we are going to perform. So this is a data flow diagram to see the what we are going to perform in this. So here we can see embedded, then load the CSV file, generate embedding, then store this into the vector database, and the with the help of that we can get the query the on the particular vector database, and then we get the data. So vector embedding we are going to perform. So now after this, key technology use vector store, LLM of GPT. I am going to use LLM model GPT 3.5 for the get the embedding. and vector store as a FASI for the fast and local vector similarity search, and vector modeling. Retrieval for the retrieval, I am going to use LangChain retrieval QA for retrieval the information from that particular vector database. And there is a API key, and this is a code that we are going to use for the creation of the vector embedding. And after creation of vector embedding, with the help of this code, here you can see the model name, and I am going to use the summarization on that particular vector CS vector database, and by querying we get the response. So these are the second phase I am going to perform now. So for this second phase, I want code. So I am going to ask ChatGPT. So ChatGPT, for I want code to uh, I have embedding code in the vector database. So code for this. So here you can say we have to install the this pip install OpenAI LangChain plus CPU pandas Python. So I already show that I install all these packages, and this is a code to do this operation. And the for local search on vector similarity, this is a code load and search on vector database. So I am going to use this. I want to affordable good quality of product or anything, any query I want to perform. So I'm going to use this code for the search. So now I'm go there in my VS code. So here you can see review embedding. So so here you can see this is a I import the .env from my OpenAPI key from here. Then I use the OpenAI embedding. Then LangChain as a import FAISS as a vector database. And I give the path. This is my review dot file, and with the help of OpenAI embedding, OpenAI API key, I convert this into the this what we can say the vector database, and this store to the vector store. So now I'm going to run this file. Wait, I have to save this file first. Yes. So here you can see after the after the run this code in that particular vector store here this database got created and pickle file also got created in index.faiss. Here this is a vector database got created, and after database created I querying on that particular vector database, and after that I retrieval low them student social rate order continue more degree review also student expect nearly action, and reduce although discourse score necessary challenge number of class reality per goal TV struggle trade. So these are the review I getting from these and reviews, and I have to explain to summarize this text. So summary also I get result. I don't have enough specific detail example accurate summarize the top complaint for review within the rating score is 2. So and this is code for the reviewing for I want affordable good quality product, and the with the help of review this review file summarize the top complaint for review with rating less than or greater than 2. So and lastly I have to print the summary. So after summary response here I get summary what I query summarize the top complaints from review within the rating less than 2. Result, I don't have enough specific information to provide summary detail of complaint of rating 2. So these are the reviews, five top five reviews, and with the help of that five top review, I get the summaries here. So this is the I question answering on the that word vector database with the help of OpenAI API key, and get the summaries on that review part. Next part is ML model training and ML flow tracking. Um so here we are going to use the train the model with the help of the machine learning algorithm. This is a regression problem, and the with the help of transaction.csv, we're going to train the model. Uh, so here you can see transaction.csv file. Here you can see the transaction ID, customer ID, product ID, account, timestamp, payment method. So these are the transaction.py file, and payment method regarding the PayPal, bank transfer, credit card, how it will they do. So this is my data set. So now second phase regarding to I have to train the model using random forest, log metrics, then after training the model, I have to I have to monitor the model performance with the help of ML flow, and with the help of ML flow UI, ML flow UI we can track our model performance. So now I'm going to train the model. So for that purpose, I have the code uh, for the yes. This is a code for the training the model. So here is a transition.csu I imported. Then here I perform feature engineering. So I this timestamp I converted into date time. Then date of week I converted into date of week. Hours timestamp I converted into hour. In X feature I take day, hour, payment method, and Y I take amount. And then column transform I perform on payment method, and then prepare the pipeline with the n estimator of 100 and random state is a 42, and I use a random forest regressor for to train the model. After training the model, I split the data into training and testing set, and with the ML of ML flow, with the ML flow, I start showing the what will be the my accuracy, or what will be my R2 score, or what how my model performing. So I'm going to perform this task to train the machine learning model. So model got completed, training completed. So I am now using the ML flow UI, this command. I am going to hit the check the UI flow. For that purpose, I have to go to the localhost and check the wait. Okay, this is my uh, yes. So this is my now created 1 minute ago. This is my model are here prediction part. So this is my model 1 minute ago created. This is my model. So with the help of this model, I we can track the model uh, and perform the action. But now its status is ready created 1 minute ago. R2 score, MSME. R2 score is not good, so we have to do some feature engineering in next part to improve the model performance. So after that completion of the ML plot, so next phase is regarding the to ML flow. Next part is regarding now next part is with the help of Prothambus or Grafana, we have to get the output with the we have to monitor the our model. So phase 1, phase 2 completed, phase 3 also completed, phase 3 also completed. Now phase 4 is regarding to see the Grafana, Grafana and Prothambus. So this now this is my Prothambus client file. So here this is a code to see the from Prothambus client import HTTP server summary. So what is CPU uses, what Python uses, what CPU consumption, all things are we can show with the help of this Grafana. So I press Control C and here uh, Control C and interrupt the my this ML flow. And now I show the show you the this Grafana packet. Uh, we have to go to the localhost 800. So here you can see the collection of the all the GPU, CPU, Python, which are going to do all the monitoring is going to do process time, HTTP process time second, CPU load. And so now with the help of this Grafana, we can see, wait, side. Yes. Now this is a Prothambus, uh, and this is my Grafana. So here you can see I add the my this what uh, localhost 9090. This is for the Grafana. So after that, sir, I can here use the localhost 9090. Wait, wait, wrong. Wait. ProThrumbus server connection is, this is, sorry, this is a ProThrumbus server connection. So I have to run this query, execute this query. So with the help of this query, I get the information of the my CPU with the help of graphs. Here you can see how my graph is performing and the my CPU uses. There is also, here you can see explanation also, and the here you can see timeline also. So when I execute this query, graph, when table uh, localhost instance localhost graph, we can see the graph and localhost. So this information regarding the system performance we see in the with the help of this graph. So of this part regarding to show the model's performance on the with the help of graphs ProThrumbus which inbuilt in Grafana. Here we can see with the help of this localhost 9090 we make the connection, and after successfully connection is established we save and test, and then we use the this ProThrumbus client. Now we go to the this here uh, our business query agent. Now I'm with the help I'm now querying on the this is code for the I'm going to query on the data frame which is uh, which is transaction.csv, and with the help of this OpenAI key we get the all the information regarding the query. Means here I am going to ask me what is the average transaction amount for the each payment method. So with on this I get the response from this LLM regarding the what is the average transaction amount in the each payment method. So now I am interrupt this now going to run this query. Entering, so here you can see entering new agent execution chain. So final average transaction amount of each payment method, we need to group data payment method into group by operation. So action input, what you do, bank transfer, my query is transaction amount for each payment. So what is the average? So bank transfer this amount 152.0, credit card 1.6.2, PayPal this. So name and type float. Final answer, the average transaction amount for each payment method is this, and this lastly finish the chain and hit with the help of print response, you print the all the necessary information. So I retrieve this information with the help of OpenAI API key. So this is the all the details regarding the I firstly create the data set. Then with the help of the first initially I initially set up the all the environment that create a database. Then with the help of LangChain I create the vector database. After creating the vector database, I querying on a particular vector database. With the help of the ML flow, I train the model and show the model tracking with the help of ML flow. And there is a I show the ML flow model is showing on that particular localhost ML flow. Then I create the I install already I install ProThrumbus and Grafana on my system. And with the help of that CPU uses or data uses, with the help of ProThrumbus, I graphically I represent. After that, what I querying on the that my transaction CSV, and I get the information with the help of LLM agent, LLM query, and then I get the all the information, the transaction related information, and this is the all the information. So this is my last part of this demo, sir. Hello, sir.
Yeah, Rahul.
Hmm.
Okay.
Hmm.
Can you show the final Excel you showed it, right?
So no, sir, not Excel. This we get the output in the text format rather than one number with the help of LLMs.
Okay, 1 minute. So Is there any graphical representation it can show
Sir,
in Grafana?
Grafana means I'm not now very keen about Grafana because
Hmm.
I only use Prothambus is a part of Grafana. After when me like to next demo, I will import this CSV file in Grafana and show you the visualization of that particular data set. But for this,
Okay, you can also try in Power BI.
uh,
This can be converted into Excel sheet in the Python program,
hmm. Yes, yes.
and you can pull it.
Okay, sir.